Relativity and quantum mechanics are the two towering pillars of modern physics, but they fundamentally clash. Brian Greene seeks to reconcile this conflict through string theory, aiming to discover a unified law of the universe. Einstein developed the theory of special relativity based on the constancy of the speed of light. He later introduced general relativity, proposing that gravity is not a force, but the curvature of spacetime, a powerful framework for understanding the cosmos on a large scale. In contrast, quantum mechanics governs the microscopic realm of atoms and subatomic particles. With uncertainty, wave-particle duality, and probability-driven outcomes, it defies everyday logic. Famous thought experiments like Schrödinger's cat highlight its strangeness. Though mathematically precise, quantum theory often feels distant from tangible reality. String theory attempts to bridge this divide. Its core idea? Fundamental particles are not zero-dimensional points, but tiny, vibrating strings. The way each string vibrates determines whether it appears as an electron, quark, or even the hypothetical graviton, the particle believed to mediate gravity. In essence, all physical phenomena are vibrations of these strings. This opens a path toward explaining all fundamental forces, including gravity, with a single equation. However, this framework requires more than the four known dimensions. For string theory to be consistent, 6 or more extra spatial dimensions must exist, concealed in complex shapes like Calabi-Yau spaces, folded tightly beyond detection. A key component is supersymmetry, which proposes that each particle has a superpartner. This balances the equations and brings harmony to the forces of nature. Yet, experimental confirmation remains elusive. Particle accelerators like the LHC have searched for supersymmetric particles, but results have been inconclusive. Directly detecting the strings themselves is likely impossible with current technology. M-theory, an extension of string theory, envisions an 11-dimensional universe and touches on topics like the black hole information paradox and the multiverse. It sits at the intersection of cosmology and the search for a unified theory. Still, string theory faces criticism. With its vast landscape of possible solutions, it struggles to make unique, testable predictions. As such, some argue it functions more as a mathematical framework than a traditional scientific theory. Nonetheless, string theory invites us to imagine the deepest layers of existence. The idea that matter, energy, time, and space all arise from a single vibrating string blurs the lines between physics and philosophy. As Brian Greene says, the universe is more than equations, it holds beauty. Beyond science, it's this poetic vision that makes it the elegant universe.